Find the eigenvalues and eigenvectors of this matrix. So we solve the following polynomial equation. So we find the determinant of lambda I minus a, or a minus lambda I, same thing. So lambda I minus a equals 0, where I is 2 by 2 identity matrix 1 0 0 1. Then lambda I means we just multiply I by lambda, and that is now just lambda 0 0 lambda. And lambda I minus a, subtract this matrix A from lambda I. So lambda 0 0 lambda minus 2 3 3 minus 6, and we want to find the determinant of this subtraction. We'll subtract that in a moment. Determinant of, if we subtract this matrix, two matrices, then lambda minus 2, so we get lambda minus 2 there, 0 minus 3 negative 3, 0 minus 3 negative 3, lambda minus negative 6, lambda plus 6 equals 0. We can denote the matrix by bracket or parenthesis. Now let's find the determinant. For we just multiply this lambda minus 2 times lambda plus 6 minus this way negative 3 times negative 3 positive 9 equals 0. This is a polynomial, it's a second degree polynomial in lambda. Now we solve for lambda. For we need to multiply, distribute this, so FOIL lambda 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 is squared, lambda plus 6 lambda minus 2 lambda minus 12 and minus 9 equals 0. Let's combine the like terms. Lambda is squared, the 6 minus 2 4 lambda, and minus 12 minus 9 minus 21 equals 0. Let's factor. 21 is 7 times 3, 7 times 3 21, 7 minus 3 is 4, so lambda is squared. Let me factor. Okay, so this is a trinomial. When we factor in this way, lambda lambda 7 times 3 21, and to get negative we have to have one negative positive, but plus 4, so plus 7 minus 3. And from the first factor, now we got two factors. Product of two factors equals 0. That means lambda plus 7 0, so lambda equals negative 7. From this lambda equals 3. So we have now two eigenvalues. Next we need to find the corresponding eigenvectors. Okay, for we plug in here, by the way, this is lambda I minus a in terms of matrix. So let me erase this part, and we have to do twice. We have to find corresponding eigenvectors. So let's consider lambda equals negative 7. For lambda equals negative 7, to find the corresponding eigenvector, we solve this equation. So instead of determinant, we write this matrix, and vector xy, that's what we are trying to find, equals 0 vector. And lambda equals negative 7, plug in here, negative 7 minus 2, negative 9 minus 3 minus 3. This is negative, lambda is negative 7, negative 7 plus 6, negative 1. Xy equals 0. Now we need to solve the system. For let's multiply this row times column. If we multiply this way, this is negative 9x minus 3y equals 0. This row times column, so negative 3x minus 1y equals 0. And we should always get a dependent system. I mean, these two equations, if we graph, they should be parallel, and which is the case. Look at here, if we multiply second by 3, then we get the first, because 3y, 3 times 3, 9. So we get infinitely many solutions, and since they will, both of these equations produce the same set of solutions, I want to take the easy one. Let's consider the second one because this is simpler, and solve for x, y. Just write one pair. So we are finding just one out of infinitely many. Just to satisfy, if don't take 0 though. If we take, let's say, 1, then -1 other side, and divide by -3, so 1/3. How about taking x equals 1? If we take x equals 1, this is -3. Let's make +3, so -3 here, minus -3. So this is one of many correct answers. I mean, we could have taken, let's look at here, -3, we take some value minus some value, and we are trying to make 0. And I just chose 1 and -3, because -3 times 1 is -3, minus -3 means +3, so 0. So I could have taken -1, +3. -3 times -1 would have been +3, and this would have been -3. Or you can choose any other numbers. In fact, the solutions will be constant multiple of these 1, -3. We could have multiplied by -1 and or 2, 3. Anyway, we found the corresponding eigenvector for this eigenvalue, so we write eigenpair value is -7, and one of many correct answers for eigenvector is 1, -3. Okay, now we need to do the same thing for second eigenvector, eigenvalue, I meant lambda equals 3. So for lambda equals 3, again we go back here and plug in the lambda value, and we make that equals 0. So matrix and unknown, we can again write x, y or any other values equals 0, 0. Lambda, plug in lambda equals 3 here. 3 minus 2, 3 minus 2, 1, -3, -3, 3 plus 6, 9. X, y equals 0, 0. And now let's multiply this row times column. That's 1x minus 3y equals 0. This row times column, so this is -3x, -3x plus 9y equals 0. And as usual, these two equations should be dependent. That means the bigger one equation can be found by multiplying another by some constant. If we multiply first equation by -3, -3x, -3 times -3, +9y. Yeah, that's the case. So we just want to find one solution out of infinitely many. So we can ignore the second. Let's consider the first, because that's the easier one. And let's find one pair of x, y. If we take y equals 1, then this is -3. And if we take x equals 3, 3 minus -3 is 0. So this is one of many correct answers. 3, 1. So another eigenpair is now eigenvalue is 3, and one of many eigenvectors, correct eigenvectors, is 3, 1. Okay, final.